Hey, you guys, we're on to our next level, moving to level 2. We're working with concept 14 with ratios and rates, looking at rates now, unit rates specifically, and you want to be able to find and solve problems using the unit rates. All right, let's get going. All right, first thing we want to look at is what are the definitions? Well, the ratio definition you already have written down. I don't think you need to copy that down, but in your WSQ, you want to put the definition of a rate and the definition of a unit rate. What are unit rates? Well, a rate shows the relationship between two quantities, kind of like a ratio, but with different units. And we don't want to get too deep into that definition. So let's move on to the second one. What's a unit rate now? It's not just a rate, it's a unit rate. Well, a unit rate compares how much of something per one. So we knock it down per one. And you see unit rates all over the place. Through the day, you see unit rates a lot. I wrote down some examples here for you. You want to put them down of rates and unit rates. Now, we have a couple of things here. If I have 50 miles per hour, that's a unit rate. It meets the definition here. It says compares how much of something per one. Well, where's the one? Well, it's right here. I wrote it down. I put a little one here. If I can get that in there. A unit rate, like for example, if I go 50 miles per hour, that's 50 miles per 1 hour. If I can type 25 words per minute, that's 25 words per what? Per 1 minute. 12 inches per what? Per 1 foot. And 16 computers per room. Well, here's what's going to happen on your homework and your test and quiz. We're going to give you a rate, or I'm going to give you a rate. And for example, 200 miles in 4 hours, and you've got to be able to get it down to the unit rate. And so how do we do that? How do I convert all these rates into a unit rate? Well, it's easy. It's basically all you're going to do is, I'm just going to show you as a ratio here, like a rate. I'm going to say 200 miles in 4 hours. I'm just going to do what it says here. I'm going to take 200. What does this bar mean? Yep, you remember it means divide. I'm going to take 200 miles divided by, or broken up into, I'm going to break 200 into 4 hours. I'm going to break it down into 4 pieces. If I do that, take 200 divided by 4, I come up with 50 miles per hour. Now, if you don't want to write out the 50 miles per hour, the label there, what's the shortcut for miles per hour? MPH, miles per hour. Okay, so that's how you convert a rate to a unit rate. All right, and then if I take 500 divided by 20, so 500 words and 20 minutes, what are you going to do? Well, again, do what it says, divide it, because I want to know how much is that per one. How many words are in 1 minute? Well, if I divide that, yep, you get 25 words per minute. Again, 60 divided by 5. That'll give you your 12 inches per foot. 80 computers in 5 rooms. Take 80, break it into 5 pieces, and that'll tell you how much is 16 computers per room. All right, I'd like you to write this down. Star it, underline it. Per means to divide. When you see miles per hour, you basically do what it says. You take the miles divided by the hours. You see revolutions per minute on a car. Revolutions per minute, take revolutions divided by the minutes. So rate, a unit rate is really easy. You just divide the rate up. Take and divide it, and you'll knock it down to a unit rate. Why do we like these? Well, the best thing we can do with unit rates is you want to be able to compare. And I'll show you in a couple problems here. We use unit rates so we compare how fast are we going. Am I going faster than that person? Can I type faster than person? So For example, if another person does 200 words in 15 minutes, who's faster? Well, now I got to break it down into a unit rate. Then I can start to compare. All right, 2 problems. We'll wrap it up here. Whoops, kill that. All right, here we go. Jada thinks her school has more computers than Emma's school. If Jada's school has 220 computers for 880 students, and Emma's school has 660 students with 176 computers, which school has the most students per computer? Is it 5 students per computer? 2 students computer? So, do you see what I want to do? I want to compare these, and I can't just looking at them. It's too hard. So what we want to get is knock them down to their unit rate. Remember, right here, we talked about this. It's not the order of the numbers. Don't go by the order of the numbers. Go by the order of the words right here. What does it just do? What it tells you to do. Students divided by computers. So let's set this up. All right, let's look at Jada's. Jada's got what? 880. I'm going to put the students first on top. Whoa, that's an ugly 8. 880. Let's see if I can go a little better here. It's hard with the mouse. And 220. So there's my ratio, there's my rate, and I want to divide that. So I want to do, let me set up Emma's school quick. I set up Emma's school. How many students she have? 660. And this is students. This is computers. I like to label them students. And 176. So now all I have to do is divide. And that will tell me, it'll break it down to the unit rate. And then I can figure out who's got the best more computers per student. All right, let's divide that quick. So 880 divided by 220. What do we get? 4. So that's going to be 4 what though? 4 students. So you can just put an S. And then per what? 4 students per computer. So SPC. New label, SPC. All right, next one. Let's clear that out. And then 660. 660 divided by 176. And we got equals 3.75. All right, so now I got 3.75. Now, does that make really sense? Am I going to have 3 3/4 computer? No, you're not. But can I compare them? Yeah. So, or 3.75 students. I'm going to cut some of the students up per computer. So, I got to be careful the way I say it here. 3.75 students per computer. Now, you can't have 3 1/4 students, but can you compare them to see? Yeah. Jada's got 4 kids. Emma's got a little under 4 kids per computer. So, who's got the best computer situation? Right here. Emma does. She's got a little less than 4 kids per computer. All right, let's look at one more quick. And we'll go, which is a better buy? You see this all the time. And having 5 kids, diapers, whole row, which is the better price. Same thing with peanut butter. You want to always buy the big one, or do you buy the medium-sized one? So, which is a better deal? And how much do you save if you buy the cheaper jar? All right, here's another thing, little phrase you want to remember. Money always goes first. Why? Why do you want, if you want to write that down, that's a really good phrase to remember. Money, if I don't cover it up, money always goes first. So, what does that mean? Well, when you do define better buys, you want to find the price per ounce or the price per pound. The money always comes first, divided by whatever the unit is. So let's do that quick. Clear off I'm not going to write it out because it takes so much time here. So let's divide it. What do you do first? Money, 330. So I'm going to clear this off. and punch in 3.330, and that's for how much? 16 ounces. So I'm going to divide that up into 16 ounces, and I get, all right, let's write that down. So this jar, I get 0.20, like 20 cents, 625. That's a lot of numbers. All right, now let's look at the 64. Put that right there. Clear that off. And what do we got? 8.60 divided by 64. And we get, 13. So the big jar is a little cheaper. Now you want to think of money now. So I'm just going to stop right there because I really don't need to put too much more here. You got to be careful though. Tell you what happened on the MCA test here. All right, so you can see what the cheaper one is. This is going to be 13 cents. This is 20, but what is this 6 going to do to the 20? Well, it's going to kick it up to 21 cents. So I want to figure out how much do I save. Remember, the 4 is not bigger than 5 or greater, so I'm going to keep that at 13 cents. So how much do I save? Let's say, how much do you save per ounce here? If I subtract here 21 cents, 13 cents, if you subtract that, you're going to get 8 cents. If I can squeeze that in there. Okay, so 8 cents per ounce is what I'm going to save if I buy the cheaper jar. All right, so if I subtract them, that'll give me the cheaper one. All right, those are unit rates. A lot of times, all you have to do is just divide them. Okay, we'll catch you next time. Bring your questions to class if you got any, and we'll deal with them then. All right, thanks. Catch you later.